If you're a software developer, there's one thing that doesn't change. You're going to be looking at new code all the time. Or if you're like me, you're going to be looking at code you wrote a few months ago that feels like new code. In any case, what I want to talk today is about understanding large code bases. We're going to use a technology called RAG, or Retrieval-Augmented Generation, to take a bunch of files within your code base, ingest them, and then be able to make queries on them and chat with your code base. So let's go ahead and take a look at how that works. Let's start with the refresher of what RAG actually is. There's two parts to this. One is a one-time configuration step where you're creating your RAG database. The other is the runtime process. In the top workflow, you see that you take your source data, in my case, the data files, then you parse them. You're basically going to read each of those files in whatever format they are, Python, JSON, you name it. And then what you're going to do is you're going to transform them or chunk them by breaking them up into the same size pieces, potentially with some overlap between them so there are no seams between them. Next, you're going to index the data, which means that you're going to convert them to embeddings and put them into your vector database. Your embeddings are mathematical representations of your data that represent what they mean semantically. On the bottom, what you see is an LLM API flow where you're performing a query as a user. So what you see is that you send your query, and then you go through the same process of converting that text into an embedding. Now what you're able to do is match your query to all of the possible files that were in your vector database and do that very quickly at scale. When the results come back, you're able to then rank them and then add the most relevant search results that are in your database to your original query. And that's the process of grounding, or basically taking your original query and providing it with real-world information to provide a better result. Our use case today is that we want to understand the new Google ADK. We have heard about it, maybe we've poked around on a couple notebooks, and now we're ready to actually see how the code works. What if we could ingest all of it and ask it questions? Anything we're not sure about, dive a little deeper, find out more, and find out where the source of that information in the code base is. So I've got a notebook that'll help us with that. Let's move on to checking out the notebook. What we're going to do is clone the repo, copy the files into a Google Cloud storage bucket, ingest the files into a RAG corpus, and then we're going to be able to make some queries on them. Let's walk through the process. So we're using the Vertex AI RAG Engine. We could use a number of solutions. I like this because it's an end-to-end, fully managed system, and you'll see how easy it is to get started. So here we have the setup, installation, authentication, good stuff, but let's go ahead and move on and skip this part. We're going to import the libraries, of course, always a good thing. Now let's move on to where it matters, the configuration. Here in the notebook, you're going to specify a couple things. Let's point out some of the key parameters. We have the GitHub URL. That's the repository that you're going to ingest. Next, you see the project ID, which you're going to adjust your location, and then the bucket name into which you're going to copy the files. And finally, a folder path for which the files are going to be copied into. Notice that I've got a 10 megabyte maximum file size limit. That's arbitrary, but you see in Vertex RAG Engine that there are some various limits on different file sizes. So you'll see anywhere from at the low end, 1 megabyte to about 50 megabytes. This will just help with that process and simplify things, and it'll filter out some of the larger files. Next, you see an embedding model. That's what's going to be used to transform the files into embeddings. And next, you see the model that's going to be used to query and make basically chat queries against our database. Let's move on to the API clients. Here, what we're doing is we're creating a generative AI client that's going to be used in our AI operations, and then a storage client, which we use for copying the files. Let's move on to the data preparation stage. So first, we clone their GitHub repo. Pretty cool, just one line of code using the Git library we have here, and we put it onto the local notebook file system for a moment. And then what we're doing is we're checking that that bucket that we provided actually works. And next we'll be uploading those files to the bucket. So here in the upload code files to GCS section, what we see is walking through the whole set of repository files. and then uploading those that meet our criteria. Okay, so that's all of the data preparation. We're now actually getting into the RAG part. The first step is to create a Vertex AI RAG corpus. You can see here, it's not much code at all. You specify the name of the corpus, a little description so I know which corpus this is. It's the codebase files from that ADK repo. And then we specify a backend config. And here's where you can use a variety of different vector search databases. We're using the built-in offering, so very simple configuration, and we're good to go. Next, what we're going to do is ingest the files. So we will point the RAG import files method to our corpus and the GCS bucket location. And it's going to ingest all those files, and it's going to perform that chunking process with the parameters we specified of a chunk size of 500 tokens and an overlap of about 100 tokens. And remember that a token is approximately 4 characters and approximately a word length. So the next step here is we set up a RAG tool, and this is used to connect the RAG process to the Gemini model. You can also see here, this is very quick to set up. We specify the tool, the RAG store, and a couple parameters, the top K parameter of finding the top 10 most relevant chunks. And then we have a distance threshold. Remember, we talked about using a calculation to find the most close vectors or embeddings. And this is one of the parameters we use to filter out candidates. Now we're ready for the fun stuff. We can ask questions to the code base. That's all it took. So what you see here is we have our Gemini model we're calling generate content. We have a query for it, and then we have a configuration with the tool we just specified. And I've already done this here. I've ran it, and you see the response that it understood what the ADK is all about. Now, let's actually try a chat interface. The final step here is I have a step in the notebook that's going to link me directly into Vertex AI Studio using a URL that's constructed of the corpus name, the project, etc. And we'll be able to chat with it in a user interface. So we'll just be able to click on that link here. So here we are in Vertex AI Studio. And one of the key things you want to notice here is on the right side where you see tools, we have the checkbox for grounding in RAG Engine. And that's linking directly to the RAG corpus that we set up. One of the questions I've been wondering about with the ADK is how sessions work. So let's go ahead and ask a couple questions around that. How do sessions work in the ADK? And just a kind of basic question. And let's see how that works. So what happens is we get a response to summarize it, but then it's grounded, right? So we see a response that talks about specific methods and objects, and you also have references. So I have my grounding sources here. Each of these different links are going to point to files in the cloud storage bucket so I can analyze them. And I can continue to ask all kinds of questions and really understand the code base, ask follow-up questions, and so on. So what you saw here today was an overview of all it takes to set up your own RAG on your code base. And you saw how easy that was to do with Vertex AI Engine. You got a little refresher of the RAG concepts. Hope you thought this was cool. And as always, go ahead and like and subscribe if you like the content, and hope to see you on the next video. Thank you very much.